Okay, good morning. In the subject of engineering thermodynamics, today in a lecture we are going to see boiler safety valves. So we will see three different types of safety valves which are used as the boiler mountings. So first is a dead weight safety valve. As its name suggested that the weight is dead. That means we can't change the weight during its operation. Either you change the weight at the beginning during installation, but during operation you can't change the weight, so it is remain a dead, so it is called a dead weight safety valve. Now how that dead weight safety valve works? So suppose this is a boiler shell where steam is generated. On the boiler shell we mount that dead weight safety valve. So this is a actual passage through which excess steam will release. This is a steam release passage. So whenever excess steam is there, it will flow through this central path and move out through this. This is wall. When this wall is fitted on this wall seat, steam will not be allowed to move and escape from this tube. This is called a carrier, and these are the weights. Whatever be the pressure you decided to get generated in the boiler, accordingly you have to add this weight. So unless your steam reach to that particular pressure, it will not lift it and your excess steam will not be removed out. That means the weight added will decide how much pressure will be there inside the boiler. And this weight carrier is covered with outer casing. So basically this is the overall structure of dead weight safety valve. So there is an inner passage for steam removal. There is one valve guide is there, so that valve should be remain its position as it is. There is a escape path for steam, one weight carrier which carries dead weights and outer casing. Now we will see what happens if there is a excess steam is there, excess pressure is there. Now with the help of this weight we set a limit of a pressure. Once your boiler pressure, steam pressure rises and reach to lift this dead weight, then only your steam can escape out. Otherwise, this dead weight will keep this wall closed and your steam will remain entrapped. Now imagine the steam pressure is exceed the dead weight pressure. So what happened? This steam will lift whole carrier along with the wall. So steam pressure will lift whole this carrier along with the wall. Now there is a passage. Your steam can move out from this passage and get exhausted into atmosphere. And this is continue. When your inside steam pressure reduces and your dead weight force or its pressure overcome your steam pressure, then due to this dead weight safety valve again reach to its initial position and your valve get closed. So it is a very simple, just like a pressure cooker whistle. It is a dead weight safety valve only. But in boiler, we have a provision to change the weight. So if you want to reduce the steam pressure, you have to remove this dead weight. If you want to increase the steam pressure, then add a dead weight. Okay, but during operation you can't change it, so it remain a dead. So it is called a dead weight safety valve. Now next is a lever type safety valve. So as the name suggested, there is a lever. So suppose this is a your steam drum. Steam is generated inside the drum, and this is main body of this safety valve. This is valve seat, and this is a valve. When your valve is seated on this valve seat, your steam will not get a path to escape. And there is one lever. Lever is pivoted at one end. Second end, there is a gap so that this lever can be swelled. If it is moving upward, the pressure on this wall get reduced, so your steam will lift this wall and your steam get exhausted. But how to maintain a pressure? So on a second end of your lever, we applied the weight. So this weight will apply on this wall unless your steam pressure becomes sufficiently strong to lift this lever against this wall, the steam will not be escaped. Now how it will work? Suppose steam pressure is become excess, then in that case your steam will lift this wall against your dead weight and your excess pressure steam will be removed out. So as there is a lever, so we can say it is a lever type safety valve. So one side of a lever we applied a load. According to load, pressure will be increase in your boiler shell unless your boiler shell steam pressure reach to overcome this dead weight, your safety valve remain closed. Once it reach to overcome this dead weight pressure, then your safety valve along with lever get lifted and your excess steam will released. Now the last is a spring loaded safety valve. So again boiler shell. Boiler shell also called as a drum, that is a steam drum. This is a stem pipe that is through which your steam can be exhausted if valve is open, and this is divided into two branches. Valve seats, these are the valves, and this is spring loaded safety valve, so there must be a spring. Due to this arm, these both valves remain closed and center portion is attached with a spring. Now this spring always try to keep this lever towards closing position of the valve. Now imagine, suppose whatever be the spring you attach there having some specific tension, unless your steam pressure become more than that spring tension, it will not lift this lever. So imagine your steam pressure become excess to that spring tension. In that case, that steam will act on this valve, and this valve will lifted against the spring tension. As valve get lifted, so excess steam pressure will exhausted. Once pressure restore back in your steam drum or boiler shell, so your spring tension bring back this valve to its closing position and your valve get closed again. To operate all these safety valve, there is no requirement of a human interference. You can left it. Whenever excess pressure is there, valve will lifted, excess pressure will release. When your pressure restore, your valve get closed again. So there is no requirement of any human interfere to control all these operations. So these are the safety valves.